In this chapter, we're going to learn everything that is about air. So we'll start with first the composition, meaning the gases that are present in clean and dry air. So the first thing that we need to learn in this chapter is that clean and dry air is made up of 78% nitrogen, 21% oxygen, 0.03% carbon dioxide, and 0.97% noble gases, and this is mainly argon. Okay, so we need to know the gases that are present in clean and dry air. We need to know in what percentage are they present. Now, in one of the earlier chapters, when we were looking at whether a gas will sink or float in air, back then I told you that the average molecular mass of air is around 29. Okay, so how did we arrive at the number 29? Right now, after knowing the composition of gases in air, we can actually find out how we got 29. Now, the average molecular mass of air is simply the sum of the molecular masses of all the gases multiplied by the percentage present. Meaning, since air is 78% nitrogen, so it is 78 over 100 times 28, which is the molar mass of nitrogen, okay, plus 21% oxygen, which is 32, and so on. If you were to sum up the masses of all the gases present in clean and dry air multiplied by the percentage abundance, that will give you a number of 29. So that is how we obtain that the average mass of air is around 29, and for any gas with molecular mass larger than 29 will sink, and any gas with molecular mass smaller than 29 will float. Now, for those of you with limited bandwidth, meaning you find it very hard to remember all the gases and all the percentages, the minimum that you need to remember is this, that dry air is roughly 80% nitrogen and 20% oxygen. Okay, so that will usually get you through most of the MCQ questions related to air. Now, this is an example of an MCQ question related to air. So over here, what is happening is that we have 100 centimeter cube of air in the syringe on the left, and by applying a force on the plunger, we're going to force this 100 centimeter cube of air through a heated tube packed with copper. So we're going to solve this problem, we need to ask ourselves what happens when air passes through copper at a high temperature. The reaction that you need to recall is that copper will react with oxygen to form copper 2 oxide. So what this reaction does is that it will remove oxygen from the air. So when you force 100 centimeter cube of air through a heated tube of copper, the air that comes out of it, the air that's collected over here, will be without oxygen. So in order to solve this question, in order to know what is the final volume of gas collected in the syringe on the right, we need to know how much of air is oxygen. And as mentioned, you just need to know that it's roughly around 20%. Okay, so the volume of gas will be decreased by about 20%, or the final volume is simply 80% of the original volume. That would be 80 centimeter cube. This is another MCQ question that you will get related to air. So what is happening here is that we have 150 centimeter cube of air in a measuring cylinder where we have damped iron wool. Okay, iron in the presence of oxygen and moisture. Alright, it will actually react to form rust. You have learned this in the topic of metals. So essentially what this means again is that the oxygen in the air will be removed. after a long period of time. So what is the volume of air remaining in the measuring cylinder? Again, we need to recall that 20% of the air is oxygen. So the final volume, or the volume remaining, would be equals to 80% of 150. Now we have learned that clean and dry air is made up of the following gases. Okay, so if we can separate the gases, we can actually obtain the gases for use. So the question now is, how do we separate the gases? And for that, we need to think back to the topic on element, compounds and mixtures. Air is a mixture, so the gases are simply mixed together, they are not chemically combined. And to separate mixtures, we can use physical methods. So we need to now think back to the topic of purification and separation. Did we learn any method for separating gases? Answer is no. Okay, but can we convert the gas into another state where we can apply a method for separation? The answer is yes. Okay, so gases, if we apply pressure and we cool them down, we can actually convert them into liquid. Okay, we can convert air into liquid form. So now we have a mixture of liquids that can mix together very well, meaning a mixture of miscible liquids. So what can we do, which method can we use to separate them? If you can recall the topic well, that would be fractional distillation. Okay, and fractional distillation works based on the principle that the different liquids or the different liquefied gases have different boiling points. Now here are the boiling points of the three main gases in air. So we have nitrogen, oxygen and argon. So a common question that you will get is this, that which gas will be distilled first and which gas will be distilled last. So for that, we need to recall in fractional distillation, we need to heat up the liquid, and the first liquid to be collected via distillation is the one with the lowest boiling point. Okay, so first to be collected is the one with the lowest boiling point. Now many students will be able to recall this fact, but then they will still get it wrong. Reason being, now we are dealing with negative numbers. So when we are dealing with negative numbers, the larger the magnitude, the larger the number, the smaller is the actual value. Alright, so in this case, since we are looking at negative values, the one with the lowest boiling point is actually nitrogen. So nitrogen will be collected first, followed by argon, followed by oxygen. Alright, so when you are doing this part, please be extra careful that we are dealing with negative values.